Hi everyone, welcome to Javaras. In this video, we will create resource server. In the playlist, in the initial videos, we have created confidential client and public client. And in the later videos, we created authorization server. And now is the time to create resource server. We will not use any library related to security or resource server. We will build it using Scratch, but we will use Spring Boot Web so that we can expose the API endpoints. So first of all, what is resource server? Resource server is called API server as well. So, and resource server is the one role in the auth2 which consumes access token. So the client application gets access token from authorization server and then sends it back to the resource server in order to perform some actions on behalf of the user. Resource server then validates the access token, and resource server is the place where users data resides. So it holds users resources, and this is where actions are being performed on behalf of the user. Now, in order to tell the resource server that the request has all the permissions related to the request, we need to send one access token to the resource server from the client server. So let's say we are trying to send any get, post, put, delete, any kind of request to this URL. In order to send access token, we need to include that in the header. So we have one header called authorization, and its value will be bearer space and then the actual access token. And in the request body, we can send anything which is applicable to that request. Now, the important thing is this header. So in the header, we are passing access token. Now this access token is what the resource server validates whether the request is valid or not. Now there are two parts, authentication and authorization. Let's look at authentication first. So how the resource server authenticates the request. In order to um, authenticate the request, the access token should be present. If it is not present, then the request is considered not authenticated. The access token should be valid as well. So it should not be any random string. It should be a valid access token. And the access token should not have expired. It should be valid. Then another part is authorization. So in order to authorize, the request first needs to be authenticated, and then the tokens should have the required scopes for the action being taken. Let's say you are trying to read the contact, and then the resource server can specify that in order to read the contact, the access tokens should have contact.read scope, and in order to edit the contact, the access tokens should have contact.read and contact.write scopes. So the scopes are validated, and business logic can also authorize. So in the business logic, we can specify whether the given content can be read by the given access token or not. So for example, using the user ID, we can determine whether this user is allowed to access another user's contacts or not. And there can be anything else as well. Now, one important thing is how do we validate the access token? In the previous videos, we have discussed two strategies to generate the access token. First is called opaque access token, where the access token does not contain any information on its own. In that case, the resource server sends that access token to the authorization server in order to validate that. Then authorization server does some database lookup and sends back the response to the resource server. So that is the flow for validating of opaque access tokens. But we will not see that in this video. The another type of access token is self-encoded access token, in which case all the information related to the user and permission is encoded in that access token itself, and that access token is a signed access token. That means resource server needs to validate whether the signature is correct or not. In order to do that, the resource server needs the public key from the authorization server. So authorization server expose one endpoint which is called JWKS endpoint. So the resource server sends one request to authorization server on that JWK endpoint, and then it gets the public key which will be used to verify the signature of the access token, and that's how the access token is validated. Now let's say if the request is not authenticated, then what we do? So we return response with status code 401, and that means unauthorized. So don't get confused here. The name of status code 401 is unauthorized, but this means that the request is not authenticated. And then we send one header www authenticate. This has some information about realm. So here we are specifying the realm equal to Java, but generally or most of the time the realm value is basic. So if you are not dealing with realms, you don't need to specify anything. Or even if you are dealing with realms, the resource server is for particular realm only. So in that case, you can specify realm equal to basic. Then you need to specify the scopes. So what scopes are required in order for this request to be permitted. Then you put one error code and then error description. And the content type headers value should be application JSON because we need to return JSON body. So this JSON body has error code and error description. So that is it what we need to do when the request is not authenticated. Now when the request is not authorized, that means the request is authenticated but it does not have the necessary permission to perform the action. And it is called like access denied or forbidden as well. In that case, the response status code will be 403, which means forbidden or access denied. And the rest of the headers and body of the response should be same as in the not authenticated requests case. Okay, so you can find the code written on this URL, or if you scan this QR code, then also you should go to this URL. In this video, I will show you the code which is already written because it will take a lot of time if I try to write the code of resource server in the video. I will just explain the written code and then I will show you the demo. So in the demo, we will not use any client application. We will use Postman to show the demo, but I will include the code in the confidential client and public client as well, where instead of sending the request to user info endpoint, we will send the request to this resource server. But that we will not cover in this video, but the code will be available on this URL. As we have discussed that the authorization server needs to expose one endpoint from where the resource server can get the public key. So for that we have this authorization server, and in the authorization server in the realms, because we have already discussed that for each realm we will have a separate pair of private and public key. So in the realms controller we are exposing this endpoint, and here whenever the request comes here we call service.get public key, and this just gets the public key string from this key pair repository. And if you remember, key pair repository contains a map where key is the realm ID and value is the key pair. So key pair contains both private and public key pair, but we will just get the string from the public key and we will return that key. So we also return the type of the token, which is JWT token, and the algorithm used, which is RS256. That means RSA with SSA256. So that's the changes on the authorization server. Now let's go to resource server. So this is the resource server. This was not here earlier, so I created a resource server using Spring Initializer website. If I go to build.gradle, these are the dependencies I am using. So I am using Spring Boot Starter Web dependency because this is a web application and we need to expose some API endpoints. Other than that, there is no additional dependency which we are using. Now let's go to source, main, resources. So in the application.properties, now we are running it in on port 8082, and we have two properties here. The first property is auth2.auth server.realm ID. This is the realm ID. So I don't want to hardcode this realm ID inside resource server. So I have created this here. You may not need it. Instead of realm ID, you can just use basic as well. And then we have this one, JWK set URI. So this is the URI of the authorization server from where we will get the public key. Okay, now let's go here. So this is the resource server application, which is responsible for running the Spring Boot application. Let's go into crypto package and see what do we have here. First of all, we have public key entry. So this is what we will get from the authorization server. So if you remember, we had three things: type, algorithm, and key. So that's why we have created this record here so that we can send a request to the authorization server, and whatever we get, we can store that in this class object. Now we have invalid JWT exception. So this is just an exception. So if the access token is not valid, in that case, we return this or we throw this exception. We have crypto util here. So yeah, here if you see the public key, the type of public key is string, but we need the type of public key should be public key, which is inside Java.security package. For that, we have crypto util here. So what this does is it takes public key entry and it converts that into public key. So we use key factory and X509 encoded key spec to convert this string, which is public key entry to get public key, into the actual public key. Now we have crypto repository. This repository is responsible for making the request to authorization server and get back the public key entry. So here, if you see, we have two annotation here. First is component annotation, so that one bean of crypto repository will be created automatically whenever required. I am saying whenever required because here I am using lazy annotation, and I am using post construct annotation. So whenever and bean of this repository is created, just after that this method will get invoked, and then we are sending request to this JWK URI. So the JWK URI has the value of this property which we have specified in the application.properties file, and I'm using REST client. So in the constructor, the REST client dot builder is getting injected, and from that builder, I'm creating REST client. So using REST client, I'm sending request to this JWK URI. It is a GET request. Then whatever we are getting, we are retrieving its body, and so we will get a string which will be JSON string. Now we need to decode the JSON string, or we need to deserialize that JSON string into an object. So we need to specify what is the type of that object. So the type of object is public key entry. So whatever we will get back, that will be translated into public key entry class, and we will get one object. And I am assigning that return value to this instance variable. So that is crypto repository. We have looked at crypto util, invalid JWT exception, public key entry. Now let's look at JWT verifier. So this is very important. Now here I already explained this like in short when we were creating access token endpoint in the authorization server. So I will go over it one more time. If you remember, the JWT token contains three parts. The first is the header, the second is data, and the third is signature. And all three parts are joined using dot. So in the verify method, what we are doing is, okay, first we are parsing it, so that's not necessary. Yeah, let's look at parts first. So in the parts, what we are doing is we have this long string, so we are parsing that string. So first of all, we are splitting this using dot, and its length should be 3. Otherwise, it is invalid JWT token. Now, the first part is encoded header, the second part is encoded data, and the third part is encoded signature. So the encoded signature is being stored in an instance variable, and what will be the input to the signature? That will be the header plus dot plus data encoded. So input to signature will be encoded header plus dot plus encoded data, and that also we are keeping in a instance variable. Now this is the actual data. So we know that the data is base64 URL encoded. So but we need the actual data. So we are decoding it using base64 URL, and after that we will get the byte array. We need to convert that into string. So we are converting that byte array into string. Now we will have one JSON string which will represent the this object. The object type can be anything, access token or any other token. Here it will be access token only. So using object mapper, we are converting that JSON back to an object of this class. And this class we are passing while creating an object of JWT verifier. So now after completion of this parse method, we will have the token and we will have encoded signature and we will have input to signature. And those are being used here. So now in order to verify the signature, we create this signature object with this algorithm SHA-256 with RSA, because that is being used by the authorization server to sign the token. And we are using init verifying because we want to verify. So we are initializing the verification process using this public key. And this is the public key. This is coming from, whoever calls this method. And then we are updating this with this input to signature, but we want to get the bytes of this string. So that is this. We want to see whether the signature is valid or not. So for that we are calling verify method on this signature object, and we are passing the actual signature. So encoded signature, we are decoding the encoded signature. If it is not valid, then we are throwing this exception, invalid JWT exception, signature does not match. There is another verify method here, but instead of taking the public key, it takes public key entry. Now in the crypto util, we have a method which converts public key entry into public key. So we are calling that method, and then we are calling this method with that public key. And then this is the method to get the actual token or the data. So one important thing is this JWT verify. This is not only applicable for access token. This can verify any type of data, because this is a generic class. So this takes what is the type of the data, whether access token, ID token, or some other kind of token or anything. And it also takes the class. So this class will be generally this class of this type. Now let's go to contact package. In the contact package, we have first this contact. So what we are trying to build here is we are trying to build one, let's say, in application which is stores the contacts for the user. So whenever user creates a contact, the contact will be created for that user only. No other user can read, write, edit or delete some other user's contacts. So that's what we want to enforce here. So we have this contact here. The contact has four things. The ID, this is the ID of the contact, which is used to, like, let's update the contact, or if you want to face the single contact only, then also this ID is used. Then we have user ID. So this is the user ID for which this contact belongs to. So this contact can be used by the users with this user ID only. Then we have the name of the contact and email of the contact. And this is contact controller, which has some endpoints to view or edit the contacts. And this is a contact filter. So we will look at contact controller later. First, let's look at contact filter. So what we want is whenever there is a request to read a contact, then there should be access token, and that access token should have a scope contact.read. And whenever there is an another request to, let's say, create a contact or edit a contact, then the access token should contain scopes contact.read and contact.write both. That's what we want to implement. So we can implement that using filters. So in this Spring Web application, there is a chain of filters. So one request goes through all the filters. So each filter can decide whether we want to permit the request or we want to reject the request. If it permits the request, then the request goes to next filter. And if it rejects the request, then the request will not go to the next filter, and the response will be returned from that filter only. So that's what we need to do here. So let's look at this contact filter class. So first of all, this implements application context aware interface. In that case, we need to implement one method which is set application context. So what we are doing is we are getting application context here, and then we are assigning this to this instance variable. Now here we are creating two types of filters: contact read filter and contact write filter. Let's look at contact read filter only. Contact write filter is similar. in the contact read filter, so this is how we create a filter. So we are creating a bean of filter registration bean. So whenever we create a bean of filter registration bean, then from this bean we will get the object, and then that will be treated as a filter. So we are creating a filter registration bean, and here the type of filter will be contact read filter. Then we are saying set filter, new contact read filter, and this contact read filter needs application context. So we are passing that there. And we are adding these URL patterns. That means this filter will be responsible for only these paths. So if any request starts with context path, then this filter will be used. Then we have registration bean dot set enabled. That means we want to enable this filter. Obviously, if we put false here, then this filter will not be in effect, and then we are returning the registration bean. Similarly, there is another bean for contact write filter, but we will not go over that. Now this is the contact read filter, and below it we have contact write filter. So I will just collapse contact write filter. We don't want to see that. We just want to see the contact read filter. So we are getting the application context in the constructor. We have one instance variable application context. We are assigning that. Now there is another thing called access token filter helper. So we know that read filter and write filter, both of them are exactly same. They just differ in like what are the required scopes. So for the read filter, the required scopes are contact dot read, but for the write filter, the required scopes are contact dot read and contact dot write. And also they also differ in the request methods that they handle. So read filter only handles get method, but the write filter handles post, put, and delete methods. But rest of their working is same, because both the filters needs to validate the access token. So for that we have created another class access token filter helper, which will be a helper class. So this takes three things. Okay, let's look at this one. Yep. Now this filter needs three things. What are the scopes which are required? So this is a collection of a string, because each scope is nothing else but a string only. Apart from that, in order to validate the access token, it needs to know the public key as well. And for public key, we need crypto repository. So we need one crypto repository here. But here we are not sending crypto repository directly, because if we do that, then the crypto repository will not be lazily initialized. It will be eagerly initialized, and we don't want to do that. So that's why we are sending here a supplier of crypto repository. So whenever get method will be called, then at that time the bean of crypto repository will be created if it is not already there in the application context. Similarly, we have a supplier of realm here. So this will give us the realm ID. So this is supplier string, because realm ID is nothing else but string. Okay, so we are creating helper here. Now for crypto repository supplier, we are just supplying this get crypto repository method, which is getting the crypto repository from application context. Similarly, if we want to get the realm, we know that there is this property in the application.properties, which can be used to get the realm ID. So we are getting environment from the application context, and then we are getting this property from the application context and returning that value whoever wants to get the realm ID. That is it. Now this is the main method. So if you see, this contact read filter extends HTTP filter. So in the HTTP filter, there is this method do filter, which is used to filter the request, whether we want to allow the request or deny the request, or if we want to set something in the request or in the response, we can do whatever we want. Because this takes three things: request, response, and the chain. So chain is the actual filter chain. If we want to invoke the next filter in the chain, we can use this chain. First of all, I am checking that the request method should be get. Only then this filter should be applied. If the request method is not get, then we are just invoking the next filter in the chain, and then we are returning. We are not doing anything. because this is not a GET request, so we don't want to interfere. But if it is a GET request, then we are calling validate method of this helper. And now helper, in the helper we have already specified what are the required scopes, how to get the crypto repository, and how to get the realm ID. If it is valid, then if it is not valid, then we will return. We will not invoke the next filter in the chain. We want to reject the request. But if it is valid, then we are calling the next filter in the chain. So that's how contact rate filter works. Now let's go to contact write filter as well. So here only a couple of things are different. First is required scope. So required scope is contact.read and contact.write. And everything else is similar. The one more thing which is different is the request. So here we are saying that request is either should be either equal to post or it should be equal to put. So if it is neither equal to post nor equal to put, in that case we don't want to interfere with this request. So we are just saying that okay, invoke the next filter and then return. So that is the contact write filter. Now this is the access token filter helper. Um, so here we have required scopes. We have a supplier which will supply the crypto repository, and we have a supplier which will supply the realm. And this is the method validate, which is very important method. So, so this validate is taking request and response. So first of all, we know that this is access token filter helper. So we need access token in the request or in the request header. So we are getting this authorization header. So you can see this is just a content which has value authorization, but we don't want to do any spelling mistake. So that's why I'm using this constant. So we are getting this header from the request. If it is null or if it does not starts with BRR space, that means the request is not valid. In that case, we are calling this method. So we have this method error response, which is responsible for returning the error to the user. So we will look at it later. So we are passing response, and this is the status code which should go to the user, which is 401. This is the error code token absent, and this is the error description. The access token is not present, and then we are returning false. Since we need to return a boolean whether the request is valid or not, so we are returning false that the request is not valid. After that, we are getting this JWT access token from the request because we need to remove these 7 characters from the this header. So we are doing substring 7. Now access token will be new JWT verifier. So we pass this JWT access token, and then this is the type of the object. Then we call verify method. Now this is where we need to call. We need to get this crypto repository. So we are calling crypto repository supply.get, and from the crypto repository we need the public key entry, and then we are saying get token. So if anywhere let's say the token is invalid, then we will get one of these exception, and in this case I'm returning this error response. Again, the code will be 401 only because access token is present, but like it is not valid, so we are not able to parse the access token. So that's why we have this unauthorized error code, and we say invalid token. Now let's say the token is valid. Now we need to make sure that the token is not expired. So for that, first of all, we get token expiry time. So from the token, we can get the expired set. So this is just time in millisecond uh, for the expiration of the token. So we convert that into local date time. And after that, we check whether this is expired or not. If it is expired, then we send another error. So here error is invalid token, and the error description is the token is expired. So let's say instead of invalid token, we can say token expired, and we are returning false here. Now after that, token is not expired. Now we need to make sure that all the required scopes are present in the token. So what we are doing is, since access tokens scopes are space separated scopes, so we need to split this string using space array, and then we will get array of string. We will convert them to array list using arrays.aslist, and then we will convert them into set. So here we can do set as well. So we are converting them to a set, and we have required scopes as well. So we want to make sure that all the required scopes are inside available scopes. If not, then we are returning this error. Now here the status code for the response is 403, which is forbidden, because the access token is present, it is valid, it is not expired, but the access token does not have sufficient permission to perform the action, and in that case as well we are returning false. Now that's all, but now we need to get the user ID from the access token. We can get that very easily because we know that access token has one field called subject, which is the user ID. So we got the user ID. Now we need to use this user ID inside, let's say, the controllers or inside any service or anywhere. How do we do that? So for that we have created one class called user context holder, and this is a under security package. We have user context holder, and in user context holder we have a thread local variable. So what thread local variable does is it contains different values for different threads. So if we see this documentation, this class provides thread local variables. These variables differ from their normal counterparts in that each thread that access one via its say get or set method has its own independently initialized copy of the variable. Okay, that means this we can use thread local variables to store the user information. Now here we just need to store the user ID. So and that's what we are doing here. So thread local string current user ID. We have set user ID and get user ID method. Set user ID is just setting the given value to the current user ID, and get user ID is getting the value stored in current user ID. So we can use that here, user context holder dot set user ID, and we can provide the user ID here, and then we will return the true. Now let's look at this method error response. Error response takes four things: response, the status code, error, and error description. Now first of all, we set this status code to the response. After that, we need this header, this www authenticate, and its value is jw www authenticate, this whatever is this. So bearer realm equal to, we need the realm here, so we are using realm supply dot get. Then we need the scopes. So we need to tell the user or the client application that the access token should contain what are all the scopes. So we are just joining all the required scopes with space. Then this is the error and this is the description, and the same error and description should be inside the response body as well. So we have error and error description. We are sending as a JSON. So since we are sending JSON here, we need to include response.set content type application JSON and character encoding UTF-8. Let's say the access token is for updating a contact, and the access token has both the scopes contact.read and contact.write, and it is not expired as well. So do you think we should allow the request? Obviously not, because it may happen that the user 2 is trying to modify the contact for user 1. So there are some contacts which are for user 1, and there are some contacts which are for user 2. Now user 2 may be trying to modify contact which belongs to user 1. So that should also not be permittable. Now these kind of scenarios are handled by business logic, and that's what we are doing in the contact controller. So let's look at this. So we are not storing contacts in any database. We don't have any service and anything. So we just have a list of contacts, and we are initializing these contact lists in the constructor. Now, first of all, we have a get all method. So now since we have user context holder, so from the user context holder, we can get the current user ID. So we are getting current user ID, user context holder dot get user ID. So we have current user ID. Now from these contacts, we need to get all the contacts where the user ID should be equal to the current user's ID, and then we are returning them as a list. Now we want to get one contact, then so we have the ID. So user is asking for contact with this ID. So what we are doing is from the list we are getting a contact which has this ID. So we are filtering based on that. If there is no contact, then we are just returning null. But let's say there is a contact, but that belongs to different user. Then what we are doing is, so we are checking it here that this user ID of that matched contact is different than the user ID of the current user. In that case, we are throwing one exception here, access denied exception. Now I have created this exception, so I will show you after this controller how these exceptions are working. So this takes three things: error code, error description, and scopes. So this is the error code, this is the error description. So we are saying you cannot access contact with ID this, and then these are the scope that contact dot write. So we have contact dot write, but I think the scope should be contact dot read if we want to just read the contact. Now after that, we want to create a contact. So we are just creating a contact, and the user ID for the contact will be this current user's ID. Okay. Now another one is we want to update a contact. So in that case, we are getting ID of the contact and then this updated contact. So we are getting the current user ID from the user context holder. Now after that, what we are doing is from the contacts, we are filtering based on the ID of the contact. So the ID should be matched with this ID. And also the user ID should match with this current user's ID. If there is no match, then we are throwing access denied exception again. And access denied, you cannot update contact with ID this and list dot off. So instead of just having contact dot write, let's say contact dot read and contact dot write, because we know that both of these scopes are necessary in order to update the contact. If the contact exists, then we are just updating the contact here. Inside security package, we have user context holder. We have already looked at that. Then we have security exception. So this is a security exception. So this takes error description, then the list of scopes and the status. What should be the status which should be returned to the user? That's 401 or 403 or something else. Then we have authentication exception. So this authentication exception is child of security exception or subclass of security exception, where it specifies the status as unauthorized. Another is access denied exception, which is also subclass of security exception, which specifies the status code as forbidden, that is 403. Okay, that is it. Now we are throwing the exception, but we need to handle that exception, right? So for that we have security controller advice. I am annotating it with REST controller advice. We don't need to have controller advice in that case. And we are making it highest precedence. Okay, now how we are handling this exception. So whenever we are getting security exception, so first we are getting a problem detail. So problem detail, its status should be what is the status of this exception. Then we are set title will be the error, then detail will be error description. Also we are setting two more properties, error and error description. And after that we need to create, so the problem detail is ready. Now we are getting header. So this header is same as the header which we are creating in the contact filter. So I want to go over this again. So here BRRL, so as we are using Java here, so instead here as well we could have injected that value here, but let's not do that now. Then another header, content type application JSON, then charset UTF-8, and then we are building it and then we are returning it. I guess we have covered everything. Now it's time to test it. So if I say docker ps, okay, so this is the SQL server is running for authorization server. Now let's run the authorization server as well. And gradle boot run. I'm inside authorization server folder and I am running this gradle boot run command. So this would start up the authorization server. Okay, it's taking some time. Okay, it is started. Now let's go to confidential, sorry, not confidential client. We need to go to resource server. And here as well, I will say gradle boot run. Boot run. So here this should run the resource server Spring application and it is running. Now let's go to Postman. Okay, so we are here in the Postman and we have this realms. Let's get all the realms whether the realm exists or not. Okay, we have this one realm with ID Java. Okay, that's good. Let's go to scopes. Okay, so I think we have scopes as well. Now let's go to clients. I will get all the clients first. So let's create a new add request. Get all clients. So we will pass get request to localhost 9000 because the authorization server is running on port 9000. Then we need realms Java clients. Send the request. Okay, this is a client and this is a confidential client. So that is fine. So we have this client here and these are all the requests to resource server. Let's first send request to read contacts. So we want to read contact. Now this token obviously is expired. So if we send it, let's send this request to read the contacts. Now you can see that the status is 401 unauthorized. If we see headers, in the headers we have www authenticate and its value is bearer realm equal to Java scope contact.read because we are trying to read the contact. So it's contact.read only. Error at token expired and at description the access token is expired. Now I have already tested this application with the correct access token. So it has been like 1 or 2 days. So this token is expired. So that's why we are seeing token expired here. Now you might be wondering, how can we see this token expired here, right? Because if you remember in the token response, we were sending access token, refresh token, and also token expired scene. That means after how many seconds the token will expire. So using that, the postman is able to know that the token is expired. Now, when we click on this refresh button, it will send another request to the authorization server to get the access token using the refresh token. But we have not implemented that, so we will not do that. But so that's why I have this expired token here. So that is for reading the context. So let's say if we want to write a contact and if I send this request, now also I am sending this token expired 401 unauthorized. Let's go to headers, authenticate, bearer realm equal to Java, scope equal to contact.write and contact.read. So you can see we are sending the correct scopes as well in the header. So that's all. Um, we need to test for the expired token. Now let's test without any token. I will go to authorization. So let's go to read contacts only. Go to authorization and here, let's say instead of token, I will say VCD here and send it. Now you see invalid token. The access token is not valid because obviously the token is not valid. Okay, now we know that it is working. And if we don't send any token as well, then we see that token absent. The access token is not present. Now that's all. Now, but we need to get some token. So let's do that. I will first manage tokens and delete expired tokens. So now we don't have any token. Now we can create a new token. So for that, in the Postman, I have specified some parameters here. The first is token name. So I will just say token for user one, let's say. Then the grant type is authorization code. This is the callback URL, okay, which is correct. We can see that as well in the clients, get all client, we can see we have registered these callback URLs 8081 auth callback and 127.0.0.1 8081 auth callback. This would work. Then this is auth URL. So this is auth endpoint of the authorization server. This is the access token endpoint. This is the client ID. Let's see the client ID is correct or not. Let's just okay. So I think it is correct. DC and X6I. DC and X6. Okay, client ID is correct, and this client secret is also correct. So I have generated client secret using this generate client secret API endpoint. So this is correct. Now we need to give scopes, open ID, profile, email, contact.read and contact.write. Okay. After that in state, so in the state we can give any random string, and we want to send client credentials in body because that's how we have implemented authorization server. Now we are sending grant type authorization code. So let's get a new access token. Click here. Now here we need to specify the username and password. So the user is there are two users for this realm created in the authorization server, user 1 and user 3. So I'm logging in using user 1. Click on sign in. Now it is asking for read your contact and edit your contact. Let's not give the edit permission for now and click on allow. Proceed. Now you can see this is the token response. So token name and this is access token. Token type bearer expires in. So this is how the postman is able to know that our access token is expired or not. This is the refresh token because refresh token is just a random ID, and this is refresh token expires in. This access token URL where we send the request, and there are many other parameters. Let's just click on use token. So now we will use this token, and now since we are reading all the contacts, let's send this request. Now we can see we are getting two contacts. First John and the second is Peter. So let's see the contact controller. Okay, we have John and Peter. So these two are for user one and the another two are for user three, Smith and Raj. We will check that as well later. Now we are getting the contacts. Now there is another for read one contact. We are trying to read contact with ID. Let's say 4. Send it. Now we can see token expired. Okay. So let's use this token for user one. Click on send. Now we can see status is 403, access denied. This is the title and this is the error. Detail is you cannot access contact with ID 4 because contact with ID 4 belongs to user 3. Even if we try to read contact with, let's say, ID 5, click on send, and we are getting null. So that means the reading the contact is working. Let's try to write a contact. So first of all, I will try to write a contact, this ABCDEF, send token expired obviously because here I need to use this token. You are not allowed to access contacts. Okay, and if I go to headers, we are getting this scope contact write contact read. That is because after logging in, we unticked the checkbox to write the contact. So that's why we are not able to write any contact. So this is the power of auth 2, that client application asked for the request to write the contact, but user declined it. And the resource server also knows that the user did not give permission to write contact to this client application. So the resource server will not allow writing to contact. Now, but we want to write it. So let's get another contact. So I will say, let's say manage tokens. I will delete all tokens. So now there is no token. Now we need to get new access token. The username will be user one, and the password will be this one. Now I don't want to untick anything. Click on allow. Proceed. Let's give it name. So I will get token for user one again. Use token. And let's send this request. And now we are getting this back. Now let's go to read contacts and read all the contacts. Now I think we need to select this token, send this request. Now we are getting 3 users back. So this is how we are right. Now let's try to update. First of all, let's try to update this context with ID 3. But this belongs to user 3. So first let's choose the right token for user 1. And I will try to update the contact with ID 3. Now there can be anything in the body, it doesn't matter. We will get this access denied because user ID is not matching. But let's say we will try to, update the contact with ID 5 and click on send. Now it has been updated. Let's go to read contacts again. So now we have 3 contacts. The contact with ID 5 has name ABCDEF and this email. Click on send. Now we can see we are getting the updated contact. So that is how the authentication authorization works in the resource server. So the resource server has 2 places where it can specify the authorization or access permissions. First, using the method and path of the request, and the second is using business logic, because it is not necessary that if one request is allowed using that scopes and the method and path of the request, then it should be allowed to perform anything. No, because it may happen that the request is trying to uh, request has all the permissions, but it is trying to modify or trying to perform action on behalf of some other user. So that is handled in the business logic. So that's how the resource server works. But obviously, you don't need to write resource server from scratch on your own. There are many well-tested libraries. You should always use that. With that, I will end this video. I will meet you in the next one. Thank you for watching it. Please like, share, and subscribe to my channel. Bye.